For the third set of problems, we are to find the area under the standard normal curve between two non-zero z-scores. The first problem in this set asks us to find the area under the standard normal curve between a z-score of minus 0.69 and a z-score of 2.51. Recall that the table for the area under the normal curve only reports the information, that is the proportion of the curve, between a mean of 0 and a z-score value. It does not report the area between two non-zero z-scores. So what we will have to do is look up both areas under the curve for each of our z-score values. First, we'll take the z-score of minus 0.69. Taking the absolute value of that z-score, we'll highlight the row that reports a z of 0.6 and the column that reports a z of 900th. And we'll see that the area that falls between the mean of 0 and minus 0.69 is 0.2549. We'll perform the same procedure to look up the area between the mean of 0 and a z-score of 2.51. Highlight the row that reports a z-score of 2.5 and the column that reports the z-score of 100th. And the value that appears where these two highlighted areas intersect is 0.494. On the normal curve, we first will identify where minus 0.69 will fall in the curve, and we'll see that the highlighted area of the proportion of the curve between 0 and minus 0.69 is 0.2549. We now identify where the z-score of 2.51 would fall into the curve and indicate that the area between the mean of 0 and 2.51 is 0.4940. Now recall what we're asked to find here is the area between minus 0.69 and 2.51. So we merely add those two areas together. So the entire area under the curve between a z-score of minus 0.69 and a z-score of 2.51 is 0.7489. Drawing the normal curve, we first will identify where minus 0.69 will fall in the curve, and we'll see that the highlighted area of the proportion of the curve between 0 and minus 0.69 is 0.2549. We now identify where the z-score of 2.51 would fall into the curve and indicate that the area between the mean of 0 and 2.51 is 0.4940. Now recall what we're asked to find here is the area between minus 0.69 and 2.51. So we merely add those two areas together. So the entire area under the curve between a z-score of minus 0.69 and a z-score of 2.51 is 0.7489. For the second problem in this set, we are to find the area under the standard normal curve between a z-score of minus 1.29 and a z-score of 1.62. First of all, we'll take the absolute value of minus 1.29 and highlight the row of 1.2 and the column of 900th. And we can see that 0.4015 proportion of the curve falls between the mean of 0 and a z-score of 1.29, or in this case a z-score of minus 1.29. We now highlight the row that reports a z-score of 1.6 and the column of 0.02, and we see that 0.4474 of the curve falls between the mean of 0 and a z-score of 1.62. Placing both z-score values on the curve, we see that minus 1.29 falls below the mean of 0, and the area between 0 and minus 1.29 is 0.4015 proportion. The proportion of the curve that falls between 0 and 1.62 is 0.4474. Adding those two values together to get the total area under the curve between minus 1.29 and 1.62, we see that the total area under the curve between these two z-score values is 0.8489. For the third problem in this set, we are to find the area under the standard normal curve between a z-score of 0.71 and a z-score of 1.64. Looking up the area between the mean and z-score of 0.71, we highlight the row that reports a z-score of 0.7 and the column that reports the z-score of 1/100th. We then perform the same procedure highlighting the row for the z-score of 1.6 and the column of 0.04. We now place our z-scores of 0.71 and 1.64 in their respective places on the standard normal curve, and we indicate how much of the area falls between the mean of 0 and 0.71 and the mean of 0 and a z-score of 1.64. Now in this case, what's different from what we've done before is that both z-score values fall to the same side, that is to the right of the curve. They both are positive values, so both are above the mean. We're trying to find the area that falls between the z-scores. So what we need to do in this case is take the larger area of 0.4495, subtract from that the smaller area of 0.2611, and we see what is left of 0.1884 is the area that falls between these two positive z-score values. So about 18.8% of the curve falls between a positive 0.71 z-score and a positive 1.64 z-score. The fourth problem is similar to the one we just solved, in that it asks to find the area under the standard normal curve between a z-score of 1.85 and a z-score of 2.91, both positive z-scores. So we highlight the row of 0.18 and the column of 0.05 to find the first area. Then to find the area associated with the second z-score, we highlight the row of 2.9 and the column of 1/100th. Placing both z-score values onto the normal curve, we see that both fall up towards the upper tail of the standard normal curve. An area of 0.4678 falls between the mean of 0 and a z-score of 1.85, and an area of 0.4982 falls between the mean of 0 and a z-score of 2.91. Again, we're interested in the area between the two z-scores, so since they both are on the same side of the mean, we will subtract the smaller value from the larger area. So 0.4982 minus 0.4678 results in a proportion of 0.0304. So only 3% of the area under the curve falls between these two positive z-score values. The next two problems in this set require a similar procedure that we just performed, but this time both z-score values fall to the left of the mean of 0, as they both are negative values. As we have done previously, we'll look up the absolute values of the z-scores in this problem that are reported on our table. Again, we'll look up in a table the absolute values of these z-scores. So first of all, we'll find the row of the z-score of 0.9 and the column of 0.09. We then will look up the z-score of 0.5 and the column of 0.06. Identifying where these z-score values fall, since they both are negative, they will fall below or to the left of our mean of 0. And we see the area between 0 and minus 0.99 z-score is 0.3389, and the area between 0 and minus 0.56 is 0.2123. Since both z-scores fall on the same side of the curve, we will subtract the smaller area from the larger area. 0.3389 minus 0.2123 equals 0.1266. So the area that falls between a z-score of minus 0.99 and minus 0.56 is 0.1266. For this next problem, we have to find the area under the standard normal curve between a z-score of minus 1.91 and a z-score of minus 0.85. We'll take the absolute value of each of these z-scores and find the appropriate proportions from our normal table. So we first highlight the row that reports a z-score of 1.9 and the column that reports a z-score of 100th. And then we find the row of a z-score of 0.8 and the column that reports the z-score to the 500th. Placing both z-score values to the left of our mean since they are negative, but we report the area as positive because area always is positive, cannot be negative. We see that 0.4719 proportion of the curve falls between the mean of 0, z-score of minus 1.91, and we see that 0.3023 proportion of the curve falls between the mean of 0 and a z-score of minus 0.85. Because we're interested in the area between the two z-scores, and they both fall on the same side of the curve, we'll subtract the smaller area from the larger area. So 0.4719 minus 0.3023 indicates that the proportion of the curve that falls between a z-score of minus 1.91 and 0.85 is 0.1696, or about 17% of the curve. For item G, we are to find the area under the standard normal curve between a z-score of minus 1.00 and a z-score of 1.00. Because the absolute value of minus 1.00 is 1.00, we just have to look up one z-score value in the curve. So we highlight the row that reports a z-score of 1.0 and the column that reports a z-score out to the 0/100th, and we see that the value is 0.3413. Placing both z-score values onto our normal curve, we see that 0.3413 area under the curve falls between 0 and minus 1 z-score, and 0.3413 area under the curve falls between 0 and plus 1 z-score. We add those two areas together, and we see that the total area under the curve that falls between minus 1 and 1 z-scores is 0.862, or about 86% of the area under the curve. And this is where we get from the empirical rule the figure, or the estimate, that 86% of all scores will fall between 1 and minus 1 standard deviations from the mean. For item H, we find the area between minus 2 and plus 2 z-score units, and again, because minus 2 is the same, and because the absolute value of minus 2 is 2, we again look up only one z-score value. So we highlight the row that reports z-score of 2.0 and the column that reports 0/100th, and we see the value of 0.4772. Placing both z-score values on the normal curve, we see that 0.4772 proportion of the curve falls between the mean of 0 and a z-score of minus 2, and the same proportion of the curve falls between the mean of 0 and plus 2. Because both of our z-scores are on opposite sides of the curve, we simply add those two values together, and we end up with the area between 2.0 and minus 2.0 is 0.9544 proportion of the curve. And this is where we get, from the empirical rule, the estimate that about 95% of all cases in the standard normal curve will fall between minus 2 and 2 standard deviation units. For the last problem in this set, we are to find the area under the standard normal curve between a z-score of minus 3 and a z-score of 3. Looking up a z-score of 3.0, we see that the area between a mean of 0 and a z-score of 3.0 is 0.4987. Placing both z-score values onto our standard normal curve, we see that 0.4987 proportion of the curve falls between the mean of 0 and a z-score of minus 3, and 0.4987 proportion of the curve falls between a mean of 0 and a standard and a z-score of 3. Because these z-scores are on opposite sides of the curve, we add these two areas together, and we see that the proportion of the curve that falls between -3 and 3 z-score values is 0.9974. And this is where we get from the empirical rule that 99.7% of the area under the curve falls within 3 standard deviations of the mean.